Generative AI has amazed people all over the world. Take Midjourney, for instance. It has transformed the creative process by allowing users to generate intricate and visually stunning artwork from simple text descriptions. This tool doesn't just create images, it learns and adapts, becoming increasingly proficient at interpreting and visualizing complex ideas. Then there's ChatGPT, which has redefined how we communicate by providing nuanced and contextually aware responses. It evolves through interactions, refining its conversational abilities and assisting with a wide array of tasks, from crafting eloquent emails to answering intricate questions. At its core, generative AI is powered by sophisticated machine learning algorithms, which are capable of learning from vast amounts of data and adapting their outputs based on new information. These algorithms continuously improve, making the technology more effective and versatile over time. But what if we could take this incredible technology and bring it into the physical world? Imagine robots and machines that don't just follow set instructions, but can actually learn and adapt just like their digital counterparts. Picture a robot that changes its behavior based on its surroundings, or a machine that gets better at its tasks as it interacts with people. That's the exciting promise of generative physical AI. In this video, we're going to dive into what generative physical AI is all about. We'll explore its potential benefits and peek into the fascinating future it could create. This blend of AI and the physical world is set to transform our tech experiences in ways we've only dreamed of. What is generative physical AI? In the past, artificial intelligence was predominantly seen in physical forms, robots and machines that could execute pre-programmed tasks with precision. These early AI systems were remarkable in their ability to perform repetitive tasks efficiently and accurately. Think of industrial robots on assembly lines, tirelessly working to piece together parts of a car or electronic device. However, their capabilities were quite rigid. They were designed to follow specific instructions and couldn't adapt to changes or learn from new experiences. If you wanted a robot to perform a different task, you'd need to reprogram it entirely. This rigidity limited the potential applications of physical AI, confining it largely to controlled environments where variables were minimal and predictable. As technology evolved, the advent of generative AI marked a significant shift in the landscape. Unlike their physical counterparts, generative AI systems, such as neural networks and deep learning algorithms, could learn and adapt from vast amounts of data. This new breed of AI demonstrated the ability to generate new content, such as text, images, and even music, based on patterns it observed in the data it was trained on. For example, GPT-4, a language model developed by OpenAI, can write essays, answer questions, and engage in conversations that feel remarkably human-like. However, this impressive adaptability comes with its own set of limitations. Generative AI operates solely in the digital realm, lacking the ability to interact with the physical world directly. This disconnect means that while generative AI can simulate understanding and creativity, it doesn't possess the capability to influence the physical environment or perform tangible tasks. Enter generative physical AI, a fascinating fusion of the two paradigms. This emerging technology aims to bridge the gap between the adaptable, learning nature of generative AI and the tangible, task-oriented capabilities of physical AI. Imagine robots that not only execute tasks, but also learn from their experiences and adapt to new situations in real time. These robots could assist in dynamic environments, such as disaster response, where conditions change rapidly and unpredictably. A generative physical AI could navigate through rubble, identify survivors, and adjust its strategies based on the evolving scenario. The integration of generative AI into physical forms holds the promise of creating machines that are both intelligent and capable, expanding the horizons of what robots can achieve. How does it work? Generative physical AI combines the adaptability of generative AI with the physical presence of robots. In traditional AI systems, robots followed pre-programmed instructions with little flexibility. However, by integrating generative AI, robots can now learn from their environments, make decisions based on real-time data, and adapt their actions accordingly. This involves using advanced sensors, cameras, and other data gathering tools to feed information into the AI system, which then processes this data to inform the robot's actions. Integrating AI with robotics and material sciences is key to the development of generative physical AI. Robotics provides the physical structure and mechanical capabilities, while AI brings the cognitive abilities to learn and adapt. Material sciences contribute by developing new materials that enhance the robot's functionality, such as more flexible joints, more durable components, and sensors that can mimic human senses. This integration allows robots to perform complex tasks with greater precision and adaptability than ever before. Examples of generative models that contribute to generative physical AI include generative adversarial networks, GANs, and variational autoencoders, VAEs. GANs consist of two neural networks, a generator and a discriminator, that work together to create data that is indistinguishable from real data. This technology can be used to generate realistic scenarios for robots to train on, improving their ability to handle unexpected situations. VAEs, on the other hand, encode data into a latent space and then decode it to generate new data, which can help robots understand and replicate complex patterns and behaviors. The process of learning and generating physical actions and reactions involves several steps. First, the AI system is trained on a large dataset relevant to the tasks the robot will perform. This could include visual data for object recognition, tactile data for manipulation, and environmental data for navigation. During training, the AI learns to recognize patterns and make predictions based on this data. Once deployed, the robot uses its sensors to gather real-time data from its environment, which the AI processes to make decisions. For example, a robot in a warehouse might use cameras to identify objects, determine the best way to grasp them using tactile sensors, and navigate through the space using a combination of visual and environmental data. The AI continually updates its knowledge base with new information, allowing the robot to adapt to changes and improve its performance over time. Potential application. Generative physical AI offers numerous benefits thanks to its ability to combine AI's learning capabilities with the physical adaptability of robotics. This technology can lead to more efficient processes, enhanced precision, and the ability to handle complex and dynamic tasks. One of the most promising areas for generative physical AI is autonomous robotics. These robots can perform a wide range of tasks independently, learning and adapting to their environments in real time. This is particularly useful in settings where conditions are unpredictable or hazardous, such as disaster response. Imagine robots that can navigate through rubble, locate survivors, and adapt their strategies based on the constantly changing environment. This level of autonomy and adaptability could significantly enhance rescue operations, making them faster and safer. In healthcare, generative physical AI could revolutionize the way surgeries and patient care are performed. For instance, precision surgeries can be carried out by robots that learn from each procedure, improving their techniques over time and reducing the risk of human error. These robots can assist surgeons by providing real-time data and recommendations, ensuring that operations are performed with the utmost accuracy. Additionally, in patient care, adaptive robots can help with rehabilitation, monitor vital signs, and provide personalized care based on the patient's condition and progress. The manufacturing sector stands to benefit greatly from generative physical AI as well. Adaptive production lines can adjust to new products and processes without extensive reprogramming. This flexibility allows manufacturers to respond quickly to changes in demand or design, reducing downtime and increasing efficiency. For example, a generative physical AI system could detect a defect in a product and immediately adjust the production process to correct the issue, minimizing waste and ensuring consistent quality. Smart homes and cities are another area where generative physical AI can have a significant impact. In smart homes, adaptive systems can learn the habits and preferences of the inhabitants, adjusting lighting, temperature, and security settings to create a comfortable and efficient living environment. In smart cities, these systems can manage traffic flows, optimize energy usage, and improve public safety by learning from data and adapting to changing conditions. This could lead to more sustainable and livable urban environments. The future. Looking to the future, the prospects for further advancements in generative physical AI are bright. As AI algorithms become more sophisticated and robots become more capable, we can expect even greater levels of autonomy and adaptability. This could lead to new applications that we can't yet imagine, transforming industries and daily life in ways we've only seen in science fiction. However, the rise of generative physical AI also brings potential impacts on employment. While some jobs may be displaced by automation, new job opportunities will also emerge. There will be a growing demand for skilled workers who can design, maintain, and improve these advanced AI systems. Additionally, industries that adopt generative physical AI will need personnel to oversee and integrate these technologies into their operations. Education and training programs will be essential to prepare the workforce for these new roles, ensuring that the benefits of generative physical AI are broadly shared. If you made it this far in the video, write a comment with the word AI to let us know you received the information. To stay relevant in the age of AI, check out our other videos on the channel. Thanks for watching, and we'll see you in the next video.